right, welcome everybody. My name is Jason. I was the same guy that was up there earlier. They had a cancellation last minute, so I stepped in to do a talk. So I teach a 2-day class on modern bug bounty hunting and modern red teaming. It's called the Bug Hunters methodology. And so I pulled a whole bunch of my favorite recon tricks and updates from this year into a 40-minute talk. So we're going to blast through some of this, and hopefully it's useful to you in kind of your day-to-day endeavors for being an offensive security person or a defensive security person. We'll talk about that briefly. Okay, so normally in my reconnaissance workflow, I have somewhere around, like, this isn't even all of them, but like 20 different modules to talk about, and we only have 45 minutes. So the ones we're going to talk about today are ASN discovery, using Shodan to its full effectiveness, acquisitions, cloud, and subdomain scraping. That's what we're going to talk about today. I would have liked to have tried to fit in GitHub scraping because it's really powerful, but I don't think we're going to be able to get to it, so we'll see how it goes. So in reconnaissance, reconnaissance is a subset of OSINT, meaning that we're going to look for hosts of targets, right? So you've been assigned a red team test, and it is open scope. They say, hey, act like a bad guy would. So find all of our websites, find all of our infrastructure on the internet, right? And so when I'm doing this, I learned how to do modern recon in that red teaming world, and then I transitioned into bug bounty, and it got even more competitive to try to be the first one to find a website that an organization had put online that no other hacker has hacked. And so I have refined my recon methodology, and we're going to talk about it today. But the things that we're going to look for today are these types of things. So apex domains or domains like twitch.tv, subdomains of twitch.tv of an organization, IP addresses, services, and contextual business and contextual tech intel against our targets. So those are going to be kind of the things we focus on pulling out with a whole bunch of tricks and tools and websites that I use on almost every engagement. Okay, so why are we after the first two, subdomains and apex domains? Well, if you have one website to hack, and then you find a subdomain of that website to hack, it's usually a completely different application. So you double your chances of hacking into that organization. And every time you find a new apex domain or domain, whatever word you want to say, you effectively 4x your chance of attacking that, of successfully attacking that organization and getting in. And this is because on average, every new apex domain you have will have 4 to 12 subdomains attached to it. That is the statistics that I have pulled out of my bug bounty knowledge. So like if someone stands up twitch.tv and then they also stand up twitchusers.tv, that's a new apex domain. They usually don't stand up a new apex domain unless they're going to apply a whole bunch of other applications under it. And so usually it's about 4x your chance of hacking the target. One thing about modern recon is that it's a cycle and it has some jumping around in it. And this is actually the thing that pentesters hate the most. Bug bounty hunters have accepted this, I think, in their workflow. But what happens is pentesters are very used to having a defined methodology and having an end. Whereas we'll go through some of the steps in the process for my reconnaissance workflow, and 3/4 of the way through the process, I will find a new apex domain and I have to start over and enumerate that new apex domain. So it's not a linear process, it is kind of this jumping around process. Now, a lot of people and a lot of classes you take when you do this kind of stuff, they will teach you how to use 1 or 2 tools. We might talk about those specific tools in these slides. I find my most success in this last 10%. The esoteric methods I use, the secrets that I'm going to tell you about from the bug bounty community in this talk, they're what win me bounties in the bug bounty world. It is not just downloading one tool off the shelf and scanning. It's a whole bunch of configuration you have to do. It's a whole bunch of manual steps too. Not everything's automated. And this is what wins me bounties or helps my red team or pen test engagements succeed where other people's don't. So, all right. The first module is ASNs and more. So how many of you in here know what an ASN is? Great, awesome. So autonomous system number, short code for a network, basically. An autonomous system number is applied to different size companies through the BGP routing kind of ecosystem. Basically, it's a short code for all of the owned infrastructure a company has, meaning that those are their servers, they own it usually, and that's how you route to their servers. Now, if we can at the beginning of an engagement, we can find out the ASN for a target, we're going to get a lot of IP space to scan and a lot of websites to attack. So my first stop when I do any engagement is what I call old faithful bgp.he.net. So bgp.he.net is Hurricane Electric Services. They're one of the long-standing sites that will let you do a free-form search, a keyword search here, and they will return any ASN descriptions that match here. And so here I'm looking at Twitch. I'm just looking at the keyword Twitch here for the target. Twitch has a bug bounty. I have worked on that bug bounty before. And here you can see returns two AS numbers, AS46489 and AS397153. And so this website has like almost never gone offline. It always has this free-form text search that you can use. There are other places that people tell you to use, but this is my old faithful for finding ASN numbers for places. Now, there are command line tools in the hacker world that will say that they'll find ASNs for you based on a free-form search. The problem is that when you get to fairly generic names of companies, like even Tesla, if I were to do Tesla, there are multiple companies with Tesla in their name, and so it might return IP space that's not your client. So I prefer this manual step so I never go out of scope. I can see exactly, I know Twitch Interactive is my target here, and I'm staying inside of scope. So you can click into Hurricane Electric Services, and we'll just do one live. And we can do Tesla here, make this big. Or we can just search Tesla. And then we can see that we have 3 ASNs here. So when you're on bgp.he.net, you can click inside of the ASN, and we'll just choose the first one here. We're looking at Tesla now. And you're going to look for the tab that says prefixes v4. So there's no prefixes here. There's no address space here, so we're going to ignore this ASN. It's probably been deprecated. Let's go here and go to, this one has not been visible since 2019, so we shouldn't see anything here. Nope. Let's go to their main one. And it should be here. And you go prefixes v4, so this is their IPv4 space, and here are all of their owned IP space. So this gives us a whole bunch of 24s to attack, which is quite a bit of network ranges, right? And so this is their owned IP space. I mean, they own this infrastructure mostly. You can see that they also do some stuff with other people, but mostly this is something that I'm going to notate down, and I know I'm going to attack my target on these IP ranges. I'm going to port scan them. I'm going to look for websites, things like that. Now, this is their owned infrastructure, meaning that if they're hybrid cloud, they still have cloud stuff, right? They have Azure, they have AWS and stuff like that. That is not represented in here. We'll have to use another method to find their cloud infrastructure if we want to attack them. But this is one of the first things we do. And you can basically notate these. I use this little handy browser extension here. It's called Instant Data Scraper in Chrome. And then you can just grab all of the IP blocks out of here and paste them into a spreadsheet or a mind map or wherever you want to grab all of your target's IP space. That is grabbing IP space from ASNs. Now, sometimes you will get a site that comes back, like you know the host name or you know the DNS name, right? Like Tesla.com, or in this case we're going to use state.gov. So the State Department, I did a workshop for this Recon technique, and Recon's not a crime, so I'm not doing anything illegal here. The State Department at RSA walked up to a Recon workshop I was doing, and they were like, "Hey, could you do the State Department?" And I was like, "Yeah, sure, whatever." So I put in state.gov into bgp.he.net, and what I got was they were hosted by Amazon. So if I go do that here, I can see here they're fronted by Akamai, and then if you go to website info, I mean, obviously that's the State Department website, but you go to IP info, they're hosted by Amazon. So they're hybrid cloud. Now, when I looked at this, I assumed that the State Department wasn't full cloud, right? Like that just doesn't make any sense. The State Department's an ancient entity. They have owned infrastructure, right? So I know that they're just hosting their main web page on Amazon. So I needed to figure out what their IP ranges were and what their ASN was. So the secondary place I go for this is dnschecker.org. And so dnschecker.org also has a search under the DNS lookup tab, which is here, that right there. And so I can put state.gov in here. And when you put state.gov for dnschecker.org, go to DNS lookup. So you can see that still we're looking at hosted by Amazon. But the great thing about DNS Checker is it'll look at all of their records associated to state.gov. So if I scroll down here, Amazon, 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 until we get to their MX records, which here says owner, Department of State, and AS6966. So now I have their owned IP space. I can go back to BGP, and this is a freeform search where you can also just put in the ASN, and then here I have the information and the prefixes for the Department of State. So they have a /17. That's a lot of network space to look at. I'm going to, again, look for infrastructure on this range. I'm going to look for websites and stuff like that. So. OK, you can also get ASN numbers from your registrars, things like Aaron and Ripe, to do a freeform search. In the upper right-hand corner, Aaron has a freeform search up here. It's a WHOIS search, and then you'll get back information like original AS, which is, oh, that's why it wasn't okay. AS number here, and then organization name here. So those are another way that you can get to the AS number. Now, that's finding ASN. So I said ASNs plus. Then the second thing I do when I'm doing recon on a company is I used to do this. So have any of you ever heard of this tool before, CheckMDI? Any couple people? Well, of course you have. You took my class. OK, so there was this tool, the amazing CheckMDI, that not a lot of red teamers know about, but we have been trading kind of in talks. I talk about it in my training. And what this tool did was, you know when you go work at a place and they send you a laptop, or you're working remotely and they send you a laptop and you just start working there, and they're like, connect to Outlook. And you're like, oh, OK, cool. So you open up your brand new laptop, and all they do is they give you the domain for the company. Like if you started working at Tesla, they'd say just input in tesla.com when you open up the thick client for Outlook. Behind that is a whole bunch of APIs. And so when you put in tesla.com, it goes to a Microsoft server that manages federated email and MDI and basically all kinds of information. And so it used to be that you could query one of these APIs and say, I'm going to work for Tesla. Tell me all the other email domains that Tesla manages. And it used to give you a list here of all the other email domains that Tesla manages. Now, these are new Apex domains. So I know from working on Tesla's bug bounty program, I know that they acquired Perbix. I know that they acquired Cylon. I know that they also are, I don't know if it's like a sister company, but they are also Solar City. I can see another main domain for them, teslamotors.com rather than tesla.com. And so these are all 4x opportunities for me to hack Tesla, is now that I have new Apex domains. Now, sadly, Microsoft shut down this API, I'm pretty sure because of my training, because it got spread around too much. And that was really sad. I cried the day they shut down the API. Now if you do a query for tesla.com, it just doesn't return other email domains. It'll just help you get signed up for your email at tesla.com. But hackers are very enterprising. So a guy named Michael Van Dusen, he basically, when they decided to take this API offline, they gave it a shutdown date. They said it's going to be in 2 months. Well, what Michael did is he went out and he grabbed every tenant ID on the planet, everyone that ever existed, and downloaded all of their domains from this API before it was shut down, and he made his own API for hackers to query. And so now we have a new script. It's called tenantdomains.sh, and it does the same thing, but it is a snapshot. It is a snapshot as of 3 months ago. So if they come out with a new Apex domain tomorrow, it won't be in this data set. But still, this gives us a lot to start with until we find another method for finding Apex domains that was as good as this. So if we do this here, I've already done Tesla here. So you can see here I just did bash tenant domains -d Tesla, and then it gives me back all of those Apex domains. Does anybody want to try a different domain? Maybe their work or a bug bounty target or something like that? Anyone brave?
Banko.com.
What?
Bank of America.
Bankofamerica.com. Is that the full domain? Is it BOA.com or is it? Okay.
They're here in the audience.
Great. Asking for a friend. All right, let's see what happens. Okay, so we have BAML.com, BOFA.com, BOFA Securities, EvaluServe2, Arevna2, ML.com, and Eventassurin.com. Does that look about right? This guy's like, I don't know, but yeah. Great, awesome. Now, if you do this for a huge company, which I have worked a ton on Walmart's bug bounty, there's some really interesting stuff in there. So Walmart has a ton of acquisitions and domains. Asada, which is their brand in the UK, which I think they have divested from recently, but they're still managing the email for them as of this snapshot. Jet, they have divested from, but Lighter is their South American grocery store brand. Obviously, you have all the Walmart. So you have Wal-Mart, Walmart.com, Walmart Fleet, Walmart Foundation, Walmart Health, Walmart Labs, Walmart Legal, lots of Walmart stuff. So yeah, so each one of these, I'm eventually going to scan for all the subdomains, which we'll get to at the end of the talk, but I have now exponentially increased my attack surface for these targets. Okay, now on to port scanning. So you have gotten the IP ranges from the ASNs, right? And we're gonna need to do some port scanning on those ranges eventually as a pen tester or as a red teamer. Now this is the first part where you're actually touching the target, right? Everything we've done up to this point, we haven't touched the target yet. It's all come from different sources. So, but now we're gonna actually touch the target. So a lot of people get taught in their InfoSec classes about Nmap, right? And we use Nmap for our whole lives. And I'm here to tell you that although Nmap's awesome for some things, it is not awesome for other things. Nmap is relatively slow if you compare it to other newer port scanners on the market that like predominantly bug bounty hunters use or like really up-to-date red teamers use. And so this is what we do at Arcanum. We use 3 tools in conjunction that lower our port scanning time for huge ranges down a lot. So what we first do is we take the ASN number and we pipe it in the ASN number into a tool called ASN Map, which all it does is it breaks down that ASN number into ranges that a port scanner can handle. So that's the first part of the chain. We're piping it here. And then we pass those into a port scanner called Nabu. How many of you used Nabu before? Great. So Nabu is a port scanner from a company called Project Discovery, and it is a more simple, fast, streamlined port scanner than Nmap. All it's doing is looking for a port. It's not doing any service scanning. It doesn't offer you the ability to do all the different scan types or the decoy scans or anything like that. It is just kind of a vanilla port scanner, but it is fast. It is very fast. And it has this great feature that you can add this flag right here, -nmap CLI, and then add an nmap command. So what this does is it first does the fast port scanning with Nabu, and then only when it finds an open port does it do the service scan with nmap, which reduces your time drastically to do a service scan across a large range. And then you can also add your output options here. So if you wanted to do like spreadsheet output or greppable output or whatever, you could add that inside of these ticks here. So this is what we do. Now, empirically, masscan/russcan are the 2 fastest port scanners out there. And they are very fast. The problem is that masscan and russcan is just a wrapper around masscan, so I'm gonna call them the same thing. They're very fast, but they often miss replies because they're shooting off like a machine gun in a row and not waiting for replies, whereas these 2 do. And so you will miss some ports if you use something that's too fast like masscan or russcan. But in academic purposes, head-to-head, as far as like finishing a complete scan, Rust scan is probably the fastest port scanner out there. This is what we use though. We find that this is a good workflow that both offers speed and extensibility. Okay, now if you're a red teamer and you don't want to get to the I touch my target phase yet, there is a tool called Smap. What Smap does is it's just a wrapper around a Shodan query that feels like Nmap. So you put in smap scanme.nmap.com and it looks like Nmap. It's just faking this though. It's getting all this data from Shodan. And it doesn't require an API key for, I think, up to like 100 or 200 searches or something like that. And so this is, you can do a whole port scan on one of those ranges basically with Smap, get all of the information that it has in the same format that you would get from Nmap without ever touching your target. So for red teamers, this is useful as like a first phase, like I still don't want to touch my target, but I want port information back from those ranges. So this is a tool sometimes we do. Now, if you've never used the Shodan API is a fickle mistress. It sometimes will have issues with pagination, and you won't get back all the output. So take it with a grain of salt, but it's still pretty good for what it is. Okay, oops. So next is Shodan. So when I started testing and doing bug bounty work and even pen testing, I was kind of a hater on Shodan. I was not like the person who thought that it gave me anything valuable. And then I learned about some extensions that I could use here, and so I think that they're pretty cool, so we're going to talk about those. Okay, so what are we after when we're using Shodan? Well, we want to passively, still not touch our target, gather subdomains, IP addresses, vulnerability data, and more. Okay, so manual Shodan is using the Shodan site, and this cheat sheet here, which is linked down here, I'll drop these slides in the Discord later, is probably one of the best cheat sheets I've seen. It's by Cyberwriters, and it's just like, hey, how do you do general Shodan dorking is what we call it. Remember we used to have Google dorking? Well, this is Shodan dorking. And it tells you how to use all of the search operators for Shodan if you're going to do this manually. And so if you want to do some of this manually and learn this, I suggest starting here. Now, if you do that, you're going to the Shodan GUI, and you're using those search operators, or you're putting in something, and you'll get back a whole bunch of data, but really for a massive project, this isn't exactly that useful. So one of the tools I use is called Karma. Have any of you used Karma before? No, okay. So what Karma is a wrapper around your Shodan API, and it allows you to create vulnerability checks using Shodan dorks. So you can use Karma, and here I'm using it against the Ford bug bounty. You can see Ford's mentioned down here, or the Ford Vulnerability Disclosure Program. So I have fed it a whole bunch of IPs from Ford, and it has a whole bunch of Shodan dorks built into it. So it feels like a vulnerability scanner like Nessus, like Nuclei, something like that, but you are completely not touching your target here. So it is telling me that across the ranges I've fed it, it has found 100 or 238 login pages that have the word login in the HTTP title. That's useful for me as an attacker. I want to look at every one of those for several bug types: SQL injection, default passwords. I'm going to look at all that stuff. It's got some statistics here that a lot of that stuff gave 403 forbidden or 500 error messages. But then when you get to the bottom here, you start to see some interesting stuff. So you start to see it found Jetty detect instance, 4 of them in those IP ranges. It found 6 Grafana instances which have had multiple CVEs in the last 2 years. Or it actually found 6 of those. 8 MongoDB server metrics web servers, and 1 open Spring Boot, which is really, really interesting for bug bounty hunters and red teamers, because an open actuator open to the internet is always good stuff. You can inject commands, pull down raw logs. It's great. So this is all from never touching my target. I still haven't touched Ford here. I have just got all this information from Shodan. Now, this scanner, Karma, is only as good as its definitions, but its definitions are relatively easy to write. So these are its signatures right here. Now, I know at first this might look hard to do, but it's not. You go here and you look at any of these, and it's like, okay, so the first part of this is you just name the check. So this check here is looking for a PHP info in the host name of the server. So this is just a title. Then we're using the Shodan search syntax of HTTP title. And in the title of the web page, we just want to see PHP info. And then we just want to search our target. And normally this part stays the same for every check. So when a new CVE comes out, all you have to do, like, what was the CVE that came out last week that everybody was guffawing over? It was it a new Grafana one? I can't remember. Anyway, if you want to find all the Grafana instances that your target has really quickly out of the Shodan data set, you can just make a Shodan check or a Shodan check for that in this file. So really easy to build custom checks. All right, so if you want to get good at building the Shodan dorks or Shodan checks, these are the best resources on the internet to do it. I have parsed them into this table, and they'll be in the document when I upload it later. So, all right, let's talk about acquisitions. So acquisitions will give us phishing targets, they'll give us supply chain info, but mostly they'll give us new Apex domains. If I find out that Walmart has acquired a small grocery store like, you know, Dad's Bodega or something like that, well, Dad's Bodega has a whole new Apex domain for me to attack. And so I want to find that out. So I want to know all the acquisitions of my target. So we used to use Crunchbase for this, but we have pivoted to a new site called Traxon. Traxon has a section for acquisitions. All you have to do is sign up to this site for free. Just use like a business-ish looking email. I don't think they allow regular Gmail accounts. But you can go to a company like Walmart here, and you can look at all their acquisitions. So one of the ones that happened last year that was big is Walmart acquired Vizio, which is a huge TV and technology company which had hundreds of subdomains to add to the bug bounty program. And we had a good time with that. So you will go into here, you will click into one of the acquisitions, and then when you click into Vizio, you'll go to Vizio's page, and Vizio's page will be like, what was the website for Vizio at the time of acquisition? And that's your new Apex domain. Now, a backup is pitchbook.com, and the reason that I have a backup or a secondary here, and I even have a tertiary after this, is that each of these sites have this bar of when they want to actually put an acquisition in the acquisitions list. It has to be like of a certain amount of money or something like that. And so PitchBook has actually had some acquisitions that were lower kind of on the monetary side, but they still listed them and have become really, really interesting. So Tesla does their bug bounty, and looking at Tesla in PitchBook, we found this target here that was not in any of other sources, which is they acquired Balboa Insurance Company, which is basically a small insurance company, but Tesla realized after selling so many cars for so long, they needed their own insurance company, so they purchased one, or they acquired one, which was Balboa Insurance Company, and basically took over all operations. We found many bugs on this insurance agency that we reported through the Tesla bug bounty. So acquisitions are important. All right, let's talk about Cloud Recon. So we talked about finding ASNs that lead to owned infrastructure. Well, we also want to find out if our customer is hybrid, cloud or whatever. They have owned infrastructure and stuff in the cloud, which almost every organization does these days. So we're going to use SSL certificates to find out where our target is located in the cloud. This can also yield Apex domains and internal domains, all kinds of stuff you can find by looking at SSL certificates. Now, before I move on, does anybody know what the most famous site is for inspecting SSL certificate data for subdomains is? Great. Don't fucking use cert.sh. You have been trained in many things to use cert.sh. Does anybody know what cert.sh doesn't show you? It doesn't show you any SSL certificate that renders any error at all. So if it is expired, it is self-signed, it has some sort of error, you're not getting any of those domains from cert.sh. The pagination for search.sh, search and API are horrid. Sometimes you miss whole pages of subdomains from that API. Do not use search.sh. It is bad. Okay, so for those of you who are like, what the fuck are we talking about, right? So if you've ever looked at the lock icon on your browser, you can pull up the certificate information for the website you're on, right? So I have two examples here, Ancestry.com and Nike. Let's focus on the Nike one. So inside of the Nike certificate, if you go to details, there's several metadata fields, which can also have DNS names for other sites that Nike have, which is right here. And so here inside of the certificate, by just going to Nike.com, I get a ton of other subdomains that Nike is using this certificate for. Now the 3 metadata areas that you want to look at for certificates are the common name, the organization name, and the subject alt name. Of all of those, the most important one is usually the subject alt name. And so we can go out and we can look at certificates, and if we know the domain of our target, like Nike, we can get some information. But we're trying to identify a holistic company and where they are on the cloud. So how does this play into that? Well, we can scan the entire cloud, all the clouds, Amazon, GCP, Azure. We know the IP addresses for those entire ranges. They're published publicly. We can scan all those IP addresses on port 443 and then look in those metadata places and build our own cert.sh on our own box. And so how do you do that? Well, first you got to find the IP addresses, right? So you can get them from the reachability page on AWS. These are all their EC2 domains. But this is not where I get them, but this is somewhere where they're publicly posted. There is a repo out there by a guy named Lord Alfred. I don't really know where that name Lord comes from, but he has basically all of the big host providers and cloud providers, their IP ranges updated every 24 hours on this repo. So you can pull the IP ranges for all of Cloudflare, for all of DigitalOcean, for all of Facebook's infrastructure, for all of Google, which includes Azure, AWS, everything. You can pull the ranges from this site, from this repo. Now, this is my friend Gunnar. He's a bug bounty hunter. He's one of the homies in my hacking group. He built this tool called Caduceus. How many of you have heard of Caduceus before? Oh, a couple people. Great. Amazing. OK. So what Caduceus will do is it is this SSL scanner. Now, it is custom made for doing this job of pulling certificate metadata from IPs that have SSL certificates applied to them. So it is fast as all get out. You can scan the whole Amazon range in 3 days, all of AWS in 3 days using Caduceus. So you give it the IP ranges in a file, it will go out, and it'll basically pull down every IP that hosts 443 and its certificate, and it'll parse out those 3 metadata fields. And it puts them all on one line so we can grep them. So we'll show how this works in a second. Now, if you don't want to do this yourself, there is a hacker collected called K4Jaeger. And K4Jaeger does this every 30 days. And so if you don't want to do the scanning yourself, you can go to K4Jaeger. And you can go to this URL, SNI IP ranges. And you'll see here that they'll have some old dates on them, but this right here is not indicative of anything. This is actually, these dates don't mean anything. But let's go to Amazon. The last time they scanned Amazon's full ranges was on 8/22, so relatively, what does it say? October 9, yeah. So, yeah, I mean, dates are all fucked up, but that's fine. But you go inside here, this is going to crash my browser, and you can see they visited every IP range for Amazon and what was inside the brackets there, what was inside of that certificate's SNI field or whatever. Now, what I can do is I can take this file and just grep my target name. So if my target's still Tesla.com, I just grep for Tesla.com in this file, and it will show me where every single site is that AWS site that Tesla's hosted on in their ranges. So this is how we find not their owned IP space, but their cloud IP space. You'll also see in the certificate data that you'll find other Apex domains inside the certificate data. You'll find subdomains. So this is a really great method to use. No, this is going to crash my browser because it's huge. OK, great, didn't do it. Awesome. All right, so that's K4Jaeger. If you want a grep command to make that simple, it's right there in red. I could have done this with awk much better, but I am a grep sort cut guy, so don't blame me. But yeah, so you can pull, basically all the stuff. So we're working on Dell right here, I think. Dell's bug bounty, and so this is everything we found. All the subdomains we found. That's what we were trying to pull from the certificate data in this one. So. OK, now, secondarily, as a bug bounty hunter, and maybe as a red teamer too, you want to know when your organization registers a new certificate, when they put on a new domain, or when they have a new subdomain. This is Golden's other tool, which is Chef Kiss. This is Gungnir. This will monitor all the certificate transparency projects for one domain. And then if that domain shows up in the certificate data, of any new registrations, it will alert you. And so you can have this alert to Slack, Discord, your phone, email, whatever, using a couple of other tools. And this is what we do in Bug Bounty. So Tesla registers a new site. I get pinged via Discord, or all the homies do, and we immediately start attacking that site because it's brand new. And that's what bug hunters are doing to your sites too. Sorry, that's the game. Like, we have to be faster than everybody else. Now, also good for red teamers too, right? Like, you could run this, or blue teamers. Heck, you could run this on your organization if you're a blue teamer just to see if some dev pulled out a credit card and managed to get a DNS registration through for your company, right? And just monitor what comes online. It's really interesting. We have a Discord channel to see what comes online. We see dev servers come up for only an hour at a time to do integration testing, and we'll see it in our logs, and then it goes offline forever. We can't resolve the DNS. And so we will wait until that comes back up again. And for 1 hour, we have 1 hour to hack that server. And because they think that no one will ever find it, we find some crazy stuff. There's a great talk on this by Shubham Shah from Asset Note. It's called Finding Ephemeral Vulnerabilities. It's about that specific topic. Highly recommend it.
You get pushback on those, like, they're like, oh, well, this was just development for an hour. Do you still get paid out for those?
Yeah, the question was, do we still get paid out for them? Do they give us pushback because they were only up for an hour? I mean, we don't report it. We don't report anything unless we find something critical. So one of the ones that we found was an integration server that integrated with Salesforce, Salesforce API. We managed to leak the Salesforce API key for the organization, then log into their Salesforce instance and pull down all their Salesforce data. So it's kind of hard to argue with that. So yeah. Okay, subdomain scraping. Let me see where we are on time. Oh, we're doing good on time. Great. Okay. So once you have all these Apex domains, and you've started to gather some IP ranges, and as well, you're starting to gather subdomains from some of these things, but the biggest portion of you finding hosts will be subdomain scraping. So back in the day when we used to do pen tests, the only method available for us to find subdomains was brute force. We'd have a list, and we would basically brute force like admin.tesla.com, and if it resolved, we knew there was a site there and we wanted to attack it, right? In like old school red teaming. Now, about 7 years ago, the first tool came out for subdomain scraping. Does anybody remember the first tool that came out for subdomain scraping?
Netcraft?
What?
Is it Netcraft?
No, it wasn't Netcraft, no.
Recon NG?
Recon NG is a good guess, was not Recon NG.
Sublister?
Yes, it was Sublister. Good job from the back. So Sublister was the first tool, command line tool, that basically would go out to all of these web sources. And all of these web sources here do completely different things. Some of them are security sites, some of them are certificate sources, some of them are infrastructure sites, some of them are search engines, but they all deal with DNS data. And they all have searches. And so somebody made a tool that would go out to all of these sites and say, hey, what do you know about Tesla.com? What subdomains do you know about? Now, that worked differently for each one of these sites, so they had to write a plugin for each site and how to scrape it. But eventually, they would bring back all of that information into a list and give you all the subdomains for an organization. So that was the first tool, was Sublister, to do this. Now, what is the predominant tool to do this today? Does anybody know? Louder. Oh, okay, we're going to talk about AMAS for a second. What else? SubFinder, yes. So SubFinder by Project Discovery is the predominant tool to use for this these days because it supports so many plugins. It's fast, and it handles pagination and the modules for a lot of these things really well. Now, the other person said AMAS. So AMAS is a project that I love the maintainer, Jeff Foley. He's one of my favorite people in the world. He builds a framework to monitor DNS information. But when he started AMAS, it was very similar to SubFinder, where you just put in a domain and it gave you back the output. Now it's more of this holistic kind of DNS-like monitoring framework, and it basically does not work as well for my purposes as a bug bounty hunter and just finding subdomains as I want it to. It takes forever to run. And you have to run two tools. You have to run the scan, and then when the forever scan is done, you have to run another tool to get the output. So it's just like, it doesn't work super well, at least in my opinion. Now, it's good at some things, which I have a whole section on AMAS in the full class, but ripped it out for this. But yeah, Amass and SubFinder are the two ones. The one I'm going to talk about here is SubFinder. So this is SubFinder, and it's written by Project Discovery. And here you can see it's very simple syntax at the top here. You do SubFinder -D and then your target. And it will go out to all of these sources and scrape them and pull from their APIs and give you all of the subdomains it's ever seen. Now, one thing to understand about this data is that you're going to see a subdomain here, but that doesn't necessarily mean that it will resolve, right? It just means that at some point, one of these modules that they have built saw this subdomain. It may not be online anymore. They may have pulled it or something else may have happened, but you're getting a holistic list here. So pro tip here is there's a -all flag, and we're going to need to use that in the next section when I'm talking about hooking these things up. All right, another one I do like as well, which is not up and comer, it's been out for a while, but is another tool called Beebot. And it is more of a mass type tool where it does holistic subdomain discovery. But when I benchmark these tools, part of my bug bounty and red teaming process is benchmarking these tools against each other. Beebot finds like 5 to 8% more subdomains than SubFinder finds if you just download them on GitHub and run them bare. You don't configure them at all. So I like Beebot for that reason. It gives like that 8% extra. Remember, we're trying to get to the last 10% of Recon here to be successful, so I like Beebot for that. I will just run them in parallel. I'll start SubFinder and Beebot at the same time. When they're finished, I'll take their output, cat it into a single file, and unique it. So I'll run both tools in parallel. But out of the box, everybody who's using SubFinder has already looked at all this stuff. So Twitch has a bug bounty. They have 2 domains, twitch.tv, twitch.com. Here I'm looking at twitch.com, and if this is a default run of SubFinder, every bug hunter has seen every single one of these subdomains already. Most likely, like probably 99% of them. So how do we find more stuff? Well, you have to register for some sites and add new source modules to SubFinder. So the number one priority, I'm running out of battery. The number one priority for hooking up a new source inside of SubFinder is Chaos. Project Discovery, the same company that builds SubFinder, has a separate project called Chaos. Chaos is an internet-wide DNS scanning project that is open source, but you have to sign up at their website. And when you sign up, you get an API key. And then you shove that API key inside of SubFinder, and it will query them as a source. This is a 5 to 15 percentile increase in the type and the amount of stuff you'll find, and it's absolutely free. So Chaos is the first source you should add. Next is GitHub. So by default, SubFinder will not go to GitHub and scrape domains out of source code repositories. It has that turned off, but you can turn it on and add an API key from using the classic token section, which is down here, like in developer, generate classic token. You generate a classic token, and you actually want to generate more than one. I have generated 5 sock puppet accounts for GitHub for 5 separate classic tokens from different accounts, because also the API for this is super finicky. And so what happens was you'll get automatic cooldown from searching the GitHub API. You'll miss pagination, like all kinds of issues with the GitHub search API. But if you have multiple accounts, in parallel, they can kind of make up for that. They each scan, and if they find individual stuff, they'll add it to a list, and at the end, SubFinder will give you the output. So you can enable SubFinder with as many GitHub API keys as you want, and this should be priority 2 for your subdomain scanning. Next is Shodan. Shodan's a tremendous data source, and if you have a paid API key, you can hook that up into SubFinder as well. And then there's some other cheap or free ones. Facebook, you can get a Facebook developer API key. You can use C99 for really cheap, or DNS Dumpster. So these are some other ones that you can hook up into SubFinder. Now, these are kind of the secret bug hunter, like secret sauce things. I run this course where I do a full day of Recon, and I have special guests on who are other Recon heads like me, and I have them come and do interviews. And let me just plug this in so we don't lose this real quick. Oh, yeah, that'd be great. Thank you so much. It's fine. This box doesn't already have malware, I'd be surprised. All right, thank you very much, appreciate it. Okay, so I have these people on the class as guest lecturers, and we talk about their sources. And so Shubham Shah, as I've mentioned already, He was kind of one of the biggest ones I had on, and we chopped game about what sources were the best ones for DNS data to find more subdomains than every other bug hunter. So when we got to talking, these two were Shubs's high picks right here, was DNSDB and Zetalytics, number 2 and number 3. And so these are paid services. Zetalytics costs somewhere around like $15K a year, and DNSDB costs somewhere around $30K a year. So these are things that high-powered bug bounty hunters will go in as a group and buy a license and then use it as a group and federate that cost a little bit, but to be better than other bug hunters. Now, I purchased DNSDB for my bug hunting group. We used it. It was great. Some of the cheaper options are security trails. Spiderfoot used to have an API, but they might have depreciated by now since they moved to Intel 471, since they were acquired. And then Netlist. These are good, but not great. The granddaddy of them all is Cisco Umbrella, actually. So Cisco works so close to the core routing of the internet. They have the Cisco Umbrella service and DNS query service with it. That API, if you can get access to it, it is phenomenal. It is like a 20 percentile increase of what you will find using Cisco's passive DNS data set. Now, that is an expensive service. That is a $70,000 a year service. And so I only know of a few companies who do ASM. They have their own ASM platform. In order to make their ASM platform on the back, they're actually querying the Cisco Umbrella API. I don't know of any private bug hunting groups that are doing that yet, but it is by far the best. We have baked it off against every other one of these paid things. Now, I can't reveal it because I'm sworn to secrecy, but I am going to talk around it, and if you're an enterprising bug hunter or red teamer, maybe you can figure it out. Cisco Umbrella worked with a nonprofit company to provide transparency of DNS data for a nonprofit project. And so what they did is they give their passive DNS data to this nonprofit for free, and you can go download it from this site for free as text files. Now you have to register, but you can grab it. Now a bug hunter created, or basically did the same thing as the first tool in our slide. A bug hunter downloaded all those text files, downloads them, continues to download them every month, and turned them into an API. And so basically you can get Cisco Umbrella for free. Now, I can't reveal the tool name, I can't tell you the open source project, but if you're enterprising and you want to find it, it's out there, and you can get it for free. But we're kind of sworn to secrecy in that kind of thing there. So, okay, last slide. So you have all these apexes, like these all domains and stuff like that, and you want to do subdomain enumeration on them. You've hooked up all of your API keys that you can into SubFinder. This is a one-liner that we do today right out of our automation. So I'll walk you through it. So we're stuffing all of the apexes we know about. Here it's FIS apexes. So here we were working on Fidelity Information Services, which is a financial technology company. So we put all the apexes in this text file. And then for every apex on a line in this text file, we do SubFinder on it. Then we pass it to this tool called HTTPX, which verifies if there's a web server on an IP address. That's all it does. It just looks for a web server. But it gives us the status code, the title, the content length, the web server name, the associated ASN, the geolocation, and then we throttle it at 15 threads. That's where we think mostly we stay below Akamai and Cloudflare's radar for this type of mass scanning. We look on ports 80, 8080, 443, 8443, 4443, 8888. We use a random user agent for this, and then we output it to text files. We output it to every text file that HTTPX will let us generate. So we take this, after we use this command, and we get CSV files. And then we paste our CSV files into something like this. So this is T-Mobile's Recon for our bug bounty, and you get tabs like this of each company or each Apex domain that T-Mobile has. So here is Play Octopus, PushSpring, Sprint. They acquired Sprint, and you get a timestamp from when you looked at them, the port, the URL, and the title is really useful for this type of testing. So if you make this bigger, and sometimes you don't get a title, but sometimes you do. Titles are really useful to key in on interesting websites. And so us as bug hunters will take a tab and be like, cool, I'm working on this tab today, and this is really good. So if you're a blue teamer and you want to create your own makeshift ASM, you can also do this with that command. So if you want to build your like asset management or asset profile in a spreadsheet, you can just use that command and start from here. And that's it. That's all I have for today. So this is us.